Now, how the astable multivibrator looks like. Let's check out the astable multivibrator as spoken before. They normally have odd number of NOT gates. This is the astable multivibrator. Now, astable multivibrator can also be made of XNOR gate. Let's see how it can be made using XNOR gate. This is astable multivibrator. Let's say this is one XNOR gate. This is one NOT gate. This is other NOT gate. Now, as we know, astable multivibrator can be made of NOT gates having odd number of NOT gates. But here we have two number of NOT gates. For this XNOR gate, this is XNOR. For this XNOR to act as a act as a NOT gate, that is for this circuit to act as a astable multivibrators, to have an odd number of NOT gate. That is, here XNOR gate needs to be converted into, this is XOR gate, this is XOR. XOR gate needs to be converted into NOT gate. To make it into NOT gate, we need to make it as 1, or we need to have at least one input as 1, because the property of XOR gate is, if one input is 1, then XOR gate acts as an inverter. Therefore, when one of the input is 1, the XOR gate will act as a NOT gate, and in this case there will be total 3 numbers of NOT gate. This will make as a astable multivibrator. Similarly, bistable logic devices are latches and flip-flops. And latches and flip-flops, they are similar, but the only difference between the latches and flip-flops are the method used for changing the states. In latches are 1-bit memory element. Similarly is the flip-flop. But the difference between latches is that latches don't have clocks. They don't have clocks. And flip-flops are latches with clock pulses. With clock. Therefore, the main difference between latches and flip-flop is that latches are those circuits which don't have a clock pulses associated with the change in the state, but flip-flops are those circuits, or flip-flops are a kind of latches which have clock pulses associated with the changing of the state. Now, memory elements. Memory elements are the devices which can remember value indefinitely or change value on command from its input. That is, if we input one memory, or if we input one element or one value in it, the same value can also be used for future analysis, or the same value can be used for future purposes, so that we can get a desired or required value. Thus, the memory elements play a very essential part in sequential circuit. The flip-flops are one of the type of memory elements where they store memory elements in it. That is, the flip-flops are 1-bit memory element. So let's check out how the memory elements work. Command, these are the different modes. Let's say set, reset, now memorize. That is, Qt is the current state, Qt plus 1 also denoted as Q plus, which is the next state. That is, when Qt we consider it as don't carry or don't care, we have Qt plus 1 as 1, which is the next state, which is called as a set. That is, the next state is having its value 1. Similarly, if the next state is having its value 0, that is, if Q plus is having its value 0, we consider it as a reset. That is, the value has already been reset and is ready to use with the fresh start. Similarly, if the current state is having value 0, and if we are getting the same value in the next state Q plus, which is also 0, then we can say that no memory has changed, or the same value has gone from the present state to the future state. The same is with 1. That is, when current state is 1 and if we get 1 in the next state, we can say that the same value has been transferred to the next state. Now the memory elements with clocks. As discussed, memory elements are those elements which can store 1-bit memory, and flip-flops are the memory element that changes the state on the clock signals. That is, when the memory elements are given a clock signals, they can store or they can change the value depending on the pulses of the clock, depending on whether the clock pulses are high or depending on whether the clock pulses are low. Similarly, the flip-flops are of different kind. One are edge triggered, one are level triggered. So let's check out how the positive edge or how the negative edge can be considered. Let's say clock. First of all, we'll start with the pulses. What actually are the clock pulses? Suppose let's say these are the clock pulses. So clock pulses are of different types. Similarly, we have flip-flops that work on different type of clock pulses. Like we can say edge triggered, and these are level, and the second is level triggered. So again, in edge triggered we have two types, positive and negative. Also in level we have positive level triggered and negative. Okay, so let's see these rising, these are called positive edge triggered. This falling, the falling edge of the clock pulses are called as negative edge triggered. Okay, now similarly these pulses, this one, let's draw in a clean diagram again. This part are called as positive level triggered, and this part are called as negative level triggered. These are the concept of clock pulses. The same we can see here. This one is positive edges and this one are negative edges, the one with the blue line. Similarly, the positive pulses, also called as positive levels, the upper one part are positive level pulses and the lower part, this one, are negative level pulses. The same has been explained in detail. As I've told, the memory elements have two types of triggering, that is pulse triggered, edge triggered, which is this pulse edge triggered are this one. These are the edge triggered. These are the edge triggered. Either maybe it's positive or negative. The edge triggered, positive edge triggered, positive, and this negative, and the level triggered. Level triggered are this upper parts. That is, the state of the flip-flops or the state of the sequential circuit changes when the clock is having a positive pulse, a positive level or negative level for level triggered. And similarly, the state of the flip-flop changes for positive triggered flip-flop in the way when the clock changes in positive way. That is, for this circuit, that is for flip-flops, the state changes when the clock rises from 0 to 1. From 0 to 1 for positive level triggered flip-flop, positive edge triggered flip-flop, and for negative edge triggered flip-flops, the state changes when the clock changes from 1 to 0. That is, from 1 to 0, as seen in the blue line, 1 to 0, it is for negative edge triggered.